Let's look at planes in 3D space. Now, what's a plane? A plane is a surface on which the line joining any two points lies completely on it. So what this basically means is, let's say this is the plane. Now you take any 2 points on this plane. Then if you connect these 2 points to form a line, then all the points in between these 2 points will lie on the plane. Now, in 2 dimensions, the equation of a line is ax plus by plus c equal to 0, which is a first degree equation in 2 variables. Similarly, a first degree equation in 3 variables x, y and z represents a plane. That is ax plus by plus cz plus d equal to 0. Now here a, b, c, d are the scalars. Now let's say we have 2 points on this plane, a, x1, y1, z1 and b, x2, y2 and z2. Then we can write ax1 plus by1 plus cz1 plus d equal to 0. Similarly, ax2 plus by2 plus cz2 plus d equal to 0. Now remember simultaneous linear equations. Let's multiply the first with n divided by m plus n times, and the second one with m by m plus n. Now why are we doing this? You remember one way in which we can prove that a line, all the points in between 2 points, all the points on the line connecting 2 points lie on the same plane, is by showing that each of these points divides this line in the ratio of m:n. Remember that? Then we can say that this is on the same plane, all the points. So, and when we are talking of dividing a line by in the ratio of m:n, we need to remember the section formula. Right? Now to get the section formula, we have to do this. Now let's see whether it happens or not. So let's multiply it. A x1 n by m plus n plus b y1 n by m plus n plus c z1 n by m plus n plus d by plus n is equal to 0. Similarly, a x2 m by m plus n plus b by2 m by m plus n plus c z2 m by m plus n plus d times m by m plus n equal to 0. Now let's add these two. What do we get? A is common, so let's take a out. Then we are left with nx1 plus mx2 by m plus n plus b times ny1 plus my2 by m plus n plus c times n z1 plus m z2 by m plus n plus d times n plus m by m plus n equal to 0. Now this 2 gets cancelled. So we are left with mx2 plus nx1 by m plus n a plus b times my2 plus ny1 m plus n plus c mz2 plus nz1 by m plus n plus d is equal to 0. Now this is of the same form as this, right? So which means that this represents a point mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, mz2 plus nz1 by m plus n equal to 0. And it also means that this point C lies on the line joining A and B and divides the line in the ratio m is to n, which also means that different values of m and n will give us different points on the line AB, and every point on the line AB lies entirely on the surface represented by this surface AX plus BY plus CZ plus D equal to 0. Now here if D is equal to 0 means what? That the plane is passing through origin. If D is not equal to 0, then we can write AX plus BY plus CZ plus D equal to 0, and we can divide the entire thing by D. So divide by D, divide by D, divide by D, divide by D. These two gets cancelled, and if you notice, A divided by D, B divided by D, C divided by D are nothing but constants. So let's say A by D, A1 is equal to A by D, B1 is equal to B by D, C1 is equal to C by D. Then we can say A1x plus B1y plus C1z plus 1 is equal to 0. So that means 3 independent characteristics are required for a plane. Plane XOY means what? The values would be x, y, 0, because z is not there. What this means is that the equation for this would be z equal to 0. That means what? It doesn't matter what the values of x and y are. Z will always be 0. So you can take any values of x and y and keep z equal to 0 to get the plane XOY. That means on the coordinate axis, planes on the coordinate axis. Okay. Similarly, we would have XOZ. This would be x, 0 and z. So here what this means is that it doesn't matter what the values of x and z are, y is always 0. And finally y or z, and here it's 0 comma y comma z, and here the equation would be x equal to 0. Now remember, we just looked at the fact that 3 independent characteristics are required for a plane. So that means we can write the equation of a plane can be written in different forms. So forms of equations of a plane. So let's just briefly look at that. I'll just name them, not even briefly look at them. I'll just name them, and then later we'll look at each one of them in detail. Equation of a plane passing through 3 given points. Intercept form, normal form, passing through a point and perpendicular to a vector, passing through a point and parallel to given lines. And finally we'll look at passing through 2 points and parallel to a given line. Okay, so I think that's enough for today. Bye for now.